All righty, so antiderivatives and indefinite integrals. So what we have been doing are definite integrals. We've had limits of integration. So on our integral symbol, like you see this little integral symbol here, we would have numbers here because it was a specific amount that we were integrating. This is indefinite, which means we're integrating the entire function, not just a part of it. So I want you to think, if you were given f prime of x equals 3x squared. So we took the derivative and we got 3x squared. And you were asked what function f of x had this derivative. So if I got this from the derivative, where did I start? Like what would I have taken the derivative of to get this 3x squared right here? What can I get the derivative of? Something x cubed. So x cubed. X cubed. So if I take the derivative of x cubed, then I'd get 3x squared. You agree with that? Okay, what else besides x cubed? Could be plus or minus something. So what if it was x cubed plus 1? Because it's a constant, and I'd still have the same thing, right? And what if it was x cubed plus 2, right? Or 4,000, or minus 4,000, because he said plus or minus, right? So basically, it's just x cubed plus c, where c is a constant. That's, hang on, let me write the rest of this word so I can spell, and then I'll answer your question. Where c is a constant. That looks like all one word, but where c is a constant. It's not some weird word. So the way we write it is plus c, but c could be a negative number. So c could be negative 5. Then it would be like minus 5 or whatever. Okay. We good with that? Okay, so if we take this, we take the derivative to get here. To go the other way, we can call it the antiderivative. So f of x is the antiderivative of f prime of x, and f prime of x is the derivative of f of x. Okay, we good with that? All right, so when we take the integral, remember that's kind of like undoing that derivative. And so the expression, the integral of g of x dx, this is the antiderivative of g of x with respect to x. Okay, so this part is the antiderivative of g of x with respect to x. The term indefinite integral is a synonym for antiderivative. So we know that this means to integrate. That's our integral. An indefinite integral does not have the limits of integration, and it's the same thing as antiderivative. We can talk about it either way. Okay? So let's think about our derivative rules. So we have differentiation rules on the left, integration rules on the right. So we know that if we're going to take the derivative of x to the n, we multiply by n and we subtract 1 from the exponent, right? That's how we take the derivative. So if I'm going to go the other way, I'm going to integrate x to the n. Instead of subtracting 1, I add 1. And instead of multiplying, I divide by whatever my new exponent is, right? And then the derivative of sine is cosine. So the antiderivative of cosine is sine. But notice these all have this plus c because there could have been a constant there. C can be 0. Maybe that there wasn't a constant, but we have to put that plus c when we do it, okay? So these are the derivative rules that we know. And so if you know these, especially on the trig, it's pretty easy to go backwards if you know the ones going forward. You'll get the hang of this really quickly. Remember that, what does e stand for? Easy, okay? So the derivative of e to the u is e to the u. So the antiderivative of e to the u is e to the u plus c. Okay, make sense? And then the derivative of the natural log of u is 1 over u. The antiderivative of 1 over u is the natural log of the absolute value of u. Now I want you to think about this. This is the same thing as u to the negative 1 power, right? This integration rule right here, we have x, so n cannot be negative 1. So if this was x to the negative 1 power, I can't do this. I would have to do this right here, okay? I know that's a lot of information, but we'll be able to refer back to it for a little while, and then you'll get the hang of it. It's not going to be that bad if you know how to do the other stuff. Okay? And then properties of our indefinite integrals, they're really the same as the definite integrals. If I integrate two functions being added or subtracted together, I can split them and integrate them separately. If I have a constant k times a function, I can factor that out. But remember, the multiplying and the dividing doesn't work that way. So it's the same as our definite integrals that we did. Okay? So let's see how this works. We want to integrate x to the 5th power. So remember, we're going the opposite way. We're not taking the derivative. If I was going to take the derivative, I'd multiply by 5 and subtract 1 from the exponent. Instead, I add 1, so that becomes x to the 6th, and I divide by that exponent, and then it's plus c. Okay? You could also write it as 1/6 x to the 6th. It doesn't matter either way. See how easy that is? All right? So then here, I have the integral of 1 over x cubed dx. So I would rewrite this as the integral of x to the negative 3 dx. Notice the dx stays on there until you actually take the integral. So our rule is we add 1 to the exponent. So what's our new exponent? Negative 2. And then we divide by our new exponent. And then we add c. Okay. Now, that's a safe stop. But with a negative exponent, a lot of times you will see it written as negative 1 over 2x squared plus c. Like, you need to understand that those are the same thing. Everybody okay with all that so far? All right. So just like when we're taking derivatives, if I was going to take the derivative of this, I would want to rewrite it like this first. So we're doing kind of the same thing. Same thing with the square root. Even if I was going to take the derivative, I think I'd want to rewrite this as x to the 1/2 power dx, right? Notation's important. I can't drop my integral sign. I cannot drop my dx. Right? So then I'm going to add 1 to my exponent. So what's 1/2 plus 1? 3/2. So that's x to the 3/2. And then I'm going to divide it by 3/2. So since that's a fraction, I really could just multiply by what? 2/3. And I could just make it 2/3 x to the 3/2 power plus c. Absolutely. So we could do 2x to the 3/2 over 3 plus c. Those are the same things. Either one of them is totally fine. Technically, putting it over 3/2 would be fine too. That would be less likely something you would see on a multiple choice, but either one of these, just you need to know that they're the same thing. Okay, we good with that? All right, so remember one of our integration rules is that if I have different functions, so I can look at this as 3 functions being added together, right? I could separate that into 3 integrals. I don't have to rewrite it that way. But just like if I was going to take the derivative of this, I would just take the derivative of each term if it's a polynomial, right? So we can just integrate each term here as well. So I take this first one, right? And it's 3x squared. That's going to be 3x cubed. And I divide by my new exponent, which is a 3, minus 5x to the what? Squared over 2 plus 4. So this is like 4x to the 0, so that just becomes 4x. And then you can't forget your plus c. Okay. Now, we could leave it like this. This is a safe stop. Could we also clean it up some? Okay, so we could make this into x cubed minus 5/2 x squared plus 4x plus c. I could have also left this like it was up there, either way. But. And as you're doing it, once you get the hang of it, if you realize, oh, I'm going to add 1, I'm going to divide by 3, you could just jump to this, and that's fine. I just don't want to lose you in my work right now. Okay. We good? Okay. So now I'm going to integrate sine. What do I take the derivative of to get sine? Negative cosine, because the derivative of cosine is negative sine, right? And so this, to give me sine, I would have to be negative cosine of x, and you cannot forget your plus c. What do I take the derivative of to get secant squared? Tangent. So when I integrate this, I get tangent of x, and the signs don't change there or anything, and then it's plus c. Okay. Everybody good so far? Right. So if you can take derivatives, you can do antiderivatives. You're just going backwards. That's all we're doing. All right, so there isn't a product rule or a quotient rule for antiderivatives. Okay, so there is product and quotient for taking the derivative, not for antiderivative. So we must simplify first, which means we have these two binomials. We need to FOIL this. Okay, y'all know what I mean by FOIL? Yeah, multiply them together. First, outer, inner, last. Yeah, so I'm going to take the integral of, okay, so I'm going to multiply 2x times x. When you multiply those two, what do you do with the exponents? You add them, right? Because if it was 2x times x, it would be 2x squared, right? Because I'd add the exponents that are 1. So when I multiply these two, I'm going to have a 2. And then this is x to the first and x to the 1/3. What is it? 4/3. X to the 4/3 power. Okay? Ew, I know. Then I multiply the outside 2. So 2x times 3 is going to give me 6x. The inside 2 is going to give me negative x to the 1/3 power. The outside 2 is going to give me negative 3. And these parentheses are important because if I don't have the parentheses, then the dx is only on the 3, but it's supposed to go to the whole thing. Okay? So remember, your linkage errors can cause you problems. Make sure we have all that done. So now I have it's not a polynomial because with a polynomial you have to have, you can't have fractional exponents, but either way, it's a function. I could break these up, but I can think of them broken up, but I don't have to rewrite it that way. So when I integrate, I'm going to add 1 to the exponent, right? So that'll give me 2x to the what? 7/3, right? And then I have to divide by 7/3, which means I can multiply by 3/7, right? Does that make sense? Because you divide by your new exponent, but when you divide by a fraction, you're multiplying by the reciprocal. Okay? So I went ahead and I just left this 2 here with all of that added by 1. I put it over 1 since it's a fraction, because I'm supposed to divide by that. I'd rather not put it over 7/3. I think that just makes things nasty, right? It's not wrong, but then times 7/3. All right, so then plus, so this is going to be 6x squared divided by what? 2. Okay, so since that's a whole number, I'm not going to worry about putting a fraction out front. That's fine. I just don't want to lose anybody right now. Minus, and so I add 1 to the exponent, so that's going to be x to the what? 4/3, right? And then that means I'm going to divide by 4/3, so I'm going to multiply by 3/4. You can, yeah. As you do it, I think you'll kind of learn to leave yourself a little room, like when you know what's going to happen, because I prefer for it to be in the front, but it's not wrong if it's in the back. I don't know. Okay, minus 3 what? X. Am I done? Plus c. Don't forget your plus c. So this is a safe stop right here, but again, we need to be able to clean it up. So we can either leave them all in one fraction, or we can do the fraction separately. It doesn't really matter. These don't cancel out, but this will give me 6/7 times x to the 7/3 plus 3x squared minus 3/4 x to the 4/3 minus 3x plus c. I guess I didn't need to put those over 1. I just did. Make sure. Oh, that's a different question. That's why I was checking myself, and I was like, oh, crap. Yes, this would be f, this would be f prime, yes. Very good. Okay, I have this written out somewhere and I don't know what I did with it. Okay. Are we good? Questions? Okay, so now, this one, because there is no quotient rule, just like we can get common denominators and put fractions together, we can take them apart. I don't have to rewrite this as 4 different integrals, but I do need to rewrite this as 4 different fractions. So this is the same thing as the integral of, and then I'm going to take this x to the 5th, put it over my denominator, which is x squared, minus my next term, which is 5x cubed over x squared, plus 7x over x squared, minus 4 over x squared. Okay. Any questions about what I did? So now we have common denominators. I can put it all back together one fraction. I'd end up back where I was. Okay, so we got to be able to split our fractions. We good with all that so far? Okay, so when I integrate this, I would prefer mainly to have negative exponents than stuff in the denominator, right? So I kind of want to keep that in mind when I go and clean this up. So it's the integral of, so I have x to the 5th over x squared, that's x cubed. Minus, that would be 5x, right? Plus 7x to the negative 1, right? Because I'd have x in the denominator. Minus 4x to the negative 2 dx. So I needed to do a little bit of work before I could integrate. Everybody good with that? Okay. So when I start term by term here to integrate, I do what with the exponent? Add 1. So x to the 4th divided by 4. Minus 5x to the squared, 2, divided by 2. Okay. Plus 7x to the nothing, to the 0, right? Divided by? What? Can you do that? What is that? That's nothing. Look back at your rules on the front. When we're doing this, adding 1 to the exponent and dividing, what can n not be, or x or whatever variable it was? N cannot be negative 1. You see that? All right, so what's our other option? Well, we can't do this because this is undefined. Like, that's not going to work. Look at your rules. X to the negative 1 power is the same as what?
X over 1.
1 over x, okay. How do I integrate 1 over x? It's the natural log. When you end up with some, if you're going through the motions like, ooh, look at me, I'm going 0, can't divide by 0, okay? So if this is negative 1 right here, this is the same thing as being just 7 over x, or like 1 over x. So it'd be plus, my 7 is just my 7, like that's not anything. But that 1 over x, or x to the negative 1, becomes the natural log of what?
Oh, then that's the absolute.
The absolute value of x, not of 1 of x. You're on the right track. You see why we had to do that? Again, I know that seems very obscure, but it's one of those things that you'll learn real quick because it'll keep coming up and you'll be able to handle it without a problem. Okay? So this is what this came from. So then here, minus 4x to the negative 3. Oh, not the negative 3. The what? Negative 1, sorry. Negative 1 divided by? Negative 1. Then plus c. Okay. All right, so let's clean this up a little bit. I'd have x to the 4th over 4, or 1/4 x to the 4th. I switch between writing them both ways. It doesn't matter either way. Minus 5x squared over 2. This really wasn't anything, so then we have plus 7 natural log of the absolute value of x. Now this was minus, but then I'm dividing by a negative 1, so that's really plus, right? And that would be 4 over x. Because it's not really proper to leave your negative exponents. Like, it's okay because we have safe stops, but, you know, when you kind of put them back. What questions do you have? Okay, ask me a question.
How did a negative 4x?
Because negative 4x, but I divided by a negative 1, and so those two negatives made it a positive.
Okay. How did x go in positive?
Oh, because it's to the negative 1 power, and x to the negative 1 is the same thing as 1 over x with your negative x's. Okay, good question. Anything else? Okay. Ew. All right, general and particular solutions. So a differential equation, I lost my word. Okay. Yeah. Is an equation containing a derivative. Okay. To solve differential equation means to integrate and find f of x or y, depending on what we're doing. When you first integrate, your answer with the plus c is called the general solution. Okay, it's plus some constant, which could even be 0. Then you use your initial condition to find c so that you can substitute into the general solution to find the particular solution. So we get a little bit more specific. Okay? All right. So what that means, all those wordy words. When you're told to solve the differential equation, this is my derivative. Okay? I'm going to find, and that's f prime, so I'm going to find f of x. F of x is the integral of f prime of x dx. Okay? I'm going to make you write that this one time because I want to make sure you understand what's happening. We really could kind of skip this first step most of the time. What that means here is f of x is equal to the integral, well, f prime of x is 6x squared dx. Okay? So it's fine to start here. I just want to make sure you understand what's happening. Okay? We all good with that so far? Do we know how to integrate this? Yes. So f of x is equal to, and when I integrate this, this is going to be 6x to the what? 3 divided by 3 plus c, which means f of x is equal to 2x cubed plus c. Okay, everybody good with that? And it's fine to jump here. Like if you know what's going to happen, you could write it as this and skip that part. It's fine either way. Okay, are we all good with that? So this right here, this? No, absolutely not. I just wanted to make sure, since this is new, that you understood what we're doing, how we're getting there. And this is basically what we have kind of been doing, right? We were just calling this g of x and this f of x, and knowing that it was like g prime, it just kind of looked a little bit different. No, you could just do this step and then this step and be totally fine. I just don't want to lose you right now, because I know you look down and you're writing and you're like, where the heck did that come from? So that's why in the notes a lot of times, and especially at the beginning, I write a little bit more. So this right here, this is your general solution. Right? It's not very specific because we don't know what C is. Up until now, we haven't had enough information to figure out C, but they did tell me here that I'm given f of 1 equals negative 3. Okay? So since f of 1 equals negative 3, then I can substitute in. What do I substitute in for x? 1 or negative 3? 1, because x is 1, f of x would be negative 3. So I'm going to take negative 3, that's equal to 2 times 1 cubed plus c. Right? Everybody understand where everything came from there? Okay? And so that's just 2, right? So negative 3 equals 2 plus c. So c equals what? Negative 5. So that means that f of x is equal to 2x cubed minus 5, and this is your particular solution. Okay. So you have to have a little bit more information to get there to be able to find c. Otherwise, we just, if you don't know one point in the function, you can't figure it out. But if you know one, you can find it. It's asking for f, yes. Which means you got to get all the way to f. Yes, the equation of f. And so here, when this one says solve the differential equation, we start with f prime. We got to get all the way to f, okay? So, I'm sorry, f double prime. So if I have f double prime, I can back up and I can find f prime, right? Just like if I'm going forward, I have f, I have to get f prime before I can get f double prime, right? Going backwards, if you have f double prime, you have to get f prime before you can get f, right? You got to take the same amount of steps back. So here we go. We have, so if I have f double prime, I can say that f prime of x is equal to the integral of, and it's of f double prime, but I'm just going to go ahead and write cosine of x dx. And remember, guys, notation matters. You cannot just write cosine of x. It's cosine of x dx with respect to x. Then what do we take the derivative of to get cosine? Is it negative sine? What's the derivative of sine? It's just cosine. The derivative of sine is just cosine, right? So cosine, when I go backwards, I just get sine. So that means that f prime of x is equal to sine of x plus c, right? Okay, so now I need to find this particular solution before I move on and find f. They've given me that f prime of 0 equals 3. So that means 3 equals the sine of 0 plus c. What is the sine of 0? 0. So c equals 3. So f prime of x is equal to the sine of x plus 3. Okay. Now that's just sine. I'm sorry, it is sine, but that's just f prime. I got to go back again to get f. So that means f of x is the integral of f prime, which is sine of x plus 3 dx. And notice my parentheses here. They matter because the whole thing has a dx on there if you have more than one term. Okay. So then f of x, what is the antiderivative of sine of x? Negative cosine. That's a positive sign there, right? So it has to be a negative cosine. So this is negative cosine of x plus 3x, good, plus c. So this, remember, this is my general, this is the particular, this is my general, so I got to get the particular one. They've told me that f of 0 is negative 2. So negative 2 equals negative cosine of 0 plus 3 times 0 plus c. And it's fine not to write the 3 times 0, but again, I don't want to lose you. What is cosine of 0? 1. And then since it's negative, that makes it a negative 1. This is 0 plus c. So that means that c equals what? Negative 1. So f of x is equal to negative cosine of x plus 3x minus 1. And that is your solved differential equations. Or diffie-q. There's a college course called differential equations. It's diffie-q. All right, are we good? If you can take derivatives, you can take antiderivatives. Yes, sir.
So, I guess I'm a little bit confused.
Okay.
I know it's asking me to find f double prime.
Well, they get. I'm sorry. Go ahead.
You wanted me to solve
Uh-huh.
equation,
Right.
that information?
Uh-huh.
So what exactly did we find?
We found f of x. Now that I have f of x, if you take the derivative of this function, you will get this. And then if you take the derivative of this, you get this. So just like we've started with f and gotten to the second derivative, we have now gone backwards, which will allow us to do other things. Like the why, we need to know it. We're getting there. We just got to be able to do it first.
So the question was just showing, hey, how are they connected?
How do I go backwards? Like we know how to get here and get to the double prime. If I have double prime, how do I go backwards to get to my original? Because there's been times where you've been given the derivative. It would have been nice to know what f was, right? And we didn't know, but now we know how to get there. Does that help? Does that answer your question? I think so. We're just going backwards. We're undoing it. Okay. The application of it will come, but that's a good question. All right, we good? Okay. So now let's look at this. The particle moves along the x-axis at a velocity. Ooh. Woo. Yeah. The velocity v of t, at any time t equals 2, its position is x equals 3. Okay, so p, v, a, right? It's a little a. P, v, a. So to get from position to velocity, we take the derivative. To get from velocity to position, we do what? Antiderivative. Very good. Okay, but A just says find the acceleration. We just find the regular derivative. Because this is the velocity, I want to get to the acceleration. It's just the derivative, right? We know how to take the derivative. So we have v of t. A of t then is going to be what? 12 t squared minus 6t. And that's it, right? Okay. So we want to find the position function. Okay? We have the velocity, and we want position. We usually don't use p of t. Do you remember what letter we use for position? It's actually s. I'm not sure why it's s. S of t is position. You could use p of t. It doesn't really tell you what to use, but so I want s of t. That's my position. That's equal to the integral. I don't think so. 99.9% sure. No, it doesn't matter. As long as you're finding the right function, if you call it whatever you call it. Because they didn't name it anything, then you're okay. Yeah. That's what I wrote first, and I was like, it's not P. And I was like, oh, it's S. I felt like something was weird when I was doing it. I was like, but P makes the most sense. I don't know why it's not. So I'm going to integrate, to get the position, I'm going to integrate velocity, v of t. So here, I'm just going to go ahead and write that so I don't lose anybody. And this is dt, right? Because we don't have an x. Which means that s of t is equal to the integral of 4t cubed minus 3t squared plus 5 dt. You what? Oh, okay, that's fine. Yeah, you can totally start at this step. I just want to make sure we understand what we're doing here. We're going backwards there. All right, so s of t is equal to, so I have 4t to the fourth divided by what? 4. Minus 3t to the third divided by 3. Plus 5t plus c. Yes, if you mix your variables, 100%. 100% on that one. All right, so I have s of t, which again, you could have cleaned this up as you went. Like if you knew you're about to divide by 4, it's fine. But I have t to the fourth minus t cubed plus 5t plus c. Now, do I have enough information to find, so this is my general solution. Do I have enough information to find my particular solution? Yes. When t equals 2, x equals 3. Okay? So this also sometimes is x of t, which is strange, right? That's another reason why you got to keep your variables correct. T equals 2. This is your x of t. So this is where I'm substituting in 2. And then the position is 3. So 3 goes here. That equals t, oh, well, that would be 2. 2 to the fourth minus 2 cubed plus 5 times 2 plus c. Is this a safe stop? No, you have to actually find c, right? So 3 equals 2 times 2 is 4, times 2 is 8, times 2 is 16. So I get 16 minus 8 plus 10 plus c. Okay, so it's 18. So 3 equals 18 plus c. So c equals negative 15. Which means my position, x of t or s of t equals t to the fourth minus t cubed plus 5t minus 15. Okay. We're good. There's the homework. It's not that bad, okay? What questions do you have? You've had some good questions. Yeah, it's like little puzzles. That's one thing I like about math. Hey, you never know. Well,